All right, guys, let's try this for like the 40th time. I've erased 3 videos so far, so it happens. Here we go. So on these that don't factor correctly, just look at your critical points on a graph just to kind of see where it is. So I just plug this into the graph, and you're going to find out that it's right at 1. I think is where your uh, x-intercept is. So if you can't figure it out, you need to just plug it into the x-intercept, your calculator, and you'll find it from there. But let's look at this. I'm going to show you guys what's called a sign chart. So if we're going to do maximum minimums, don't forget that what we're doing is we're taking f prime of x, that's f prime of x, and we're going to set that equal to 0. So if we're going to set that equal to 0, let's find f prime of x first. So f prime of x is going to be equal to 3x squared minus 2x minus 1. And we're going to set that equal to 0 because that's where our tangent lines are all equal to 0. That's the whole idea of our maximum minimums, because they're going to turn, and if they turn, that's where our tangent line is equal to 0. That's what we're looking for. I keep hammering that because that's a huge concept, guys. So if we take this and if we factor this out, I believe it's going to do 3x minus 1, it should be a plus. And we're going to do an x minus 1 equals 0. So I just factored that, and I get the two factors of 3x plus 1 and x minus 1. So I know that 3x plus 1 equals 0, and x minus 1 equals 0, and then x is going to equal 1, and x equals negative 1/3. So let's look at this here. So if we look at this bad boy here, we're going to take it and we're going to create a sign chart here. I'm going to do that one down here. So we're going to do a sign chart. So all I'm doing is just putting these on a number line. So I'm going to put negative 1/3 right here, and I'm going to put negative 1 right here. So I'm going to take any number between negative infinity and negative 1/3, and I'm going to plug it into f prime of x. So I'm going to take an easy one, which is negative 1. That's one of the easiest ones. So I'm going to take f of negative 1, and I'm going to say f prime of negative 1. If I plug negative 1 into f prime, I get 3 times negative 1 squared minus 2 times negative 1 minus 1. And that will give me a positive 3, a positive 2. So I get 5 minus 1, which is 4. So my value here, anywhere on this side, is a positive. A positive what? It's a positive slope. So we know between, let me change colors here. We know between, right now, between negative infinity and negative 1/3, I have a positive slope. So it's going to be going up. So I have a positive slope in between negative infinity. So it's increasing from negative infinity to negative 1/3. That's what's happening. It's increasing, positive slope. So now I'm going to go over here. Let's pick a different color here. Let's pick a different color, and let's choose green this time. So I'm going to pick a number that's really easy between these two. I'm going to pick 0 because that's super easy. So we're going to do the same thing. We're going to go f prime of 0 is equal to going to be 0 minus 1. So that's going to be negative 1. That tells us that we have a negative slope here. So that means between negative 1/3 and negative 1, it's going down. So between negative 1/3 and negative 1, on this interval, it's decreasing. So it's decreasing. So now let's go over here, and let's go and look at our last one here. And I'm going to pick, this is actually a positive one. Sorry, that is horrible. That's what happened last time. so let's do this here. Find my eraser. That one's gone. If I confused you, I'm sorry. So negative 1/3 to 1 is what we're dealing with here. All right, so I'm going to go over here and I'm going to pick 2 because it's a nice whole number. So on this side, I'm going to do f prime of 2. And so f prime of 2 is going to be 3 times 4 minus 4 minus 1. So I just plugged in 2 into that equation. So I get 12 minus 4 minus 1. That gives me a value of 7, which is positive. So that means I have a positive slope from 1 to infinity. So now I know I'm going back up after I get to negative 1. So I know I got a positive slope here, a negative slope here, and a positive slope there. All right, so now we're going to take that idea and we still have to apply our derivative here. So let's see if I get this to work right. I don't want to add a pen. I don't know why it does this sometimes. It just decides to not work correctly. So let's go with the darker color here. So now we're going to work with our f double prime of x. And if we know our f of x, I'll work up here a little bit, guys. Let's see. If I know my f of x is 3x squared minus 2x minus 1, that means this one is going to be 6x minus 2. So if I set this equal to 0, 6x minus 2 equals 0, I get x equals 1/3. So this is a possible, keyword, inflection point. Inflection point. Possible, only possible. So let's take our number line again. We're going to put it right here. And we are going to go to 1/3. Here's my 1/3. Right? So if I go to my 1/3 here and I look at this, I'm going to pick a number on the left, which is going to be, if I can find my cursor again, that's because I'm on the wrong thing. I'm going to pick 0. So f double prime of 0 is equal to what? F double prime of 0 is equal to 0 minus 2, which is equal to a negative 2. So that means f double prime of x is less than 0, which means I'm concave down. Okay, so I'm concave down all the way from negative infinity to 1/3. So it doesn't change, okay? Negative infinity to 1/3. So that means, what that tells me is that between here and here, I've got a curve that's going to be upside down, right? Like a frown. Concave down like a frown. All right, so now we're going to go over here and I'm going to plug in 1. So if I do f of 1, f double prime of 1, I'm going to get 6 minus 2, which is going to equal 4, which means that f double prime is greater than 0, which means I'm concave up like a cup. So that means I've got a curve that's going to be going up to the right. So let's just kind of look at the pieces that we have here. We know that we know quite a bit of information here. Whoops. we know that between here and here, it's going to be an increasing slope, but it has to be concave down. We know between negative 1/3 and 1, it has to be an increasing slope. Sorry, a decreasing slope, but concave down. So that kind of makes a little bit of sense there. Okay, now at 1/3, we know that it goes from a concave down to concave up. So what we have is a possible inflection point that goes from a negative to a positive. So it is a sign change. So this is an inflection point. So this is the point where we're going to go from concave down to concave up. Okay, so we have an inflection point here. So are we ready? Who knows? Let's see what we got here. So let's take this thing and let's make this work here. So we know that we have some pieces of information here. So let's look at this. So let's get our handy dandy grapher out here. So we've got our handy dandy grapher. Let's go here. And there's that one. And I'm doing, it's maybe a little longer video, but I hope it helps. We've got this one. All right, so we know we have some really important pieces at 1/3. We have them at 1. And we also know that we have a critical point over here somewhere from a graph. So let's just kind of look at this. So we have negative, and then we got negative 1/3. I forgot about that guy. So we got negative 1/3. So if we take our information, we know that I have an increasing graph to some point here at 1/3. At 1/3, it takes a turn to concave down because at 1/3, I know I have a negative slope. And then at some point right around 1/3, it changes from a concave down and starts going concave up, but it keeps decreasing until we get to 1, and then it takes back off again. So let's look at that. From negative infinity to negative 1/3, it has a positive slope, but it's concave down. Makes sense. Concave. It's a positive slope, goes to the top here, concave down. Okay? So then we go from negative 1/3 to negative 1. We have a negative slope, which it does from negative 1/3 here to negative 1 to 1. It has a negative slope, but it has an inflection at x equals 1/3, meaning it starts changing its cup. That's 1/3. It starts changing a cup. So if we look at it right here, guys, it starts doing a cup up, and this is the cup down. That's what an inflection point is right there. Then we know at 1, at 1, this is a positive 1, sorry guys, that's a positive 1. At 1 to positive infinity, we know we have a positive slope. So we know that it's going to go up. So if it changes from a negative slope to a positive slope, we know that this is a minimum. And if it changes from a positive slope to a negative slope, we know that this is a maximum. Long explanation, guys. And then you can plug your values in to find out those exact points. Don't forget, we got to plug them in. But I'm going to stop this video because it's probably really long. I don't even have a timer on it right now. So hopefully it's not too long for you guys. Let me get that pen off of there so I can actually do this. All right, guys. So let's do this. Let's close that out. And let's